Hello and welcome to another episode of Study Session for AP Physics 1. This video will be covering oscillations. So, if we, it's kind of a bit of a prerequisite into waves, simple harmonic motion and such. So let's start with some questions. So the first one says, a block is attached to an ideal spring undergoes simple harmonic motion. The acceleration of the block at a maximum, or has its maximum magnitude at the point where, so we know that we want to find acceleration equals max. And it's undergoing simple harmonic motion, so if we quickly draw a spring or something, this is going to be a ball, and this is a block, we know that's going to go back and then forth, and then back and then forth. So if we look at so we know that the formula for acceleration, A equals force over m. The mass is going to remain constant, so if we think about it, we're going to get the largest acceleration, we're going to get the largest force, right? So if we look at the formula for the force of a spring, we say that force equals negative kx, k delta x rather, delta x. So using this formula, k is a constant. We know that we'll get the largest force with the largest delta x, where your delta x is the distance it's gone from its equilibrium position. So knowing that, we know that we'll get the biggest force and subsequently the biggest acceleration at the point where it's the furthest from the equilibrium position, which is also called, it's it's called the amplitude, or it's like maximum or minimum distance or whatnot. So if we look at the answer choices, we got where the speed is its maximum, where the speed is its minimum, where the restoring force is minimum, and where the kinetic energy is maximum. So we know that the kinetic energy and subsequently the speed is going to be maximum at the center, because at that point the spring potential energy is going to be the lowest, because US equals 1/2 kx squared. So whenever the x squared is 0, you're going to have the highest potential energy, the lowest potential energy, and subsequently the highest kinetic energy and the highest speed. So we know the ones where it's saying speed is maximum and kinetic energy is maximum have to be wrong. The restoring force is this force right here. So we know that it's going to be the maximum where the acceleration is going to be the maximum, so that's wrong. And the last question is where the speed is minimum, which is true because you would expect the speed to be the minimum where the potential energy is the greatest. And where would the potential energy be the greatest? Whenever the x is the greatest. So that's how you would do that one. Okay. Next question. A block is attached to an ideal spring and undergoes simple harmonic motion about the equilibrium position x equals 0 with amplitude A. Okay? What fraction of the total energy is in the formula kinetic energy when the block is at position 1/2 A? So at 1/2 A, we want to know fraction of total energy is in kinetic energy. So we know that E total equals 1/2 k a squared, because amplitude equals max delta x. So that's our total, right? So we know that conservation of energy. We know that this will have to equal. So at 1/2 a, we've got 1/2 k 1/4 a squared, because it's k. Because the formula for US potential energy is 1/2 kx squared plus kinetic energy. So using this, we know that this right here, we know that this is a fourth of that. So if that is a fourth, we know that this has to be 75%, or 3/4 of the total potential or total energy. Because this is a fourth, like if we pull out that 1/4, it's the same as this value right over here. So we know that this is a fourth of that, meaning that this, since they're equal, the kinetic energy has to be 3/4 of that. So that was a pretty simple, pretty easy problem to just kind of logic your way through it if you can just write the equations properly. Okay, a student measures the maximum speed of a block undergoing simple harmonic motions under an oscillation amplitude of A. On the end of an ideal spring, if the object is replaced by one of twice the mass, so 2m, but the amplitude of the oscillations remain the same, then the maximum speed of the block will be. Okay, so we know that the total energy only depends on the amplitude of the system. So we know that no matter what, the U max and subsequently E max, E total equals 1/2 ka squared. So we know that that's going to remain constant. So if we solve for the first velocity, we get that 1/2 mv squared equals the first maximum velocity, rather, 1/2 ka squared. So 1/2s will cancel out, and we get that v equals a, the square root, times the square root of k over m. Okay? If we do this the second time, we get mv squared equals 1/2 ka squared. So if we do the same thing, we get v equals a times the square root of k over 2m. So if we look at this, the difference is by a factor of 1 over the square root of 2. So we know that it will decrease by a factor of square root of 2 because it's 1 over. If it was just square root of 2, then it would increase by that factor. But since it's 1 over square root of 2, it would decrease by that factor. So the velocity of the two-mass system will be decreased by a factor of square root of 2. Okay, next problem. A spring blocks simple harmonic oscillator set up so the oscillation is vertical. So let me quickly draw this. So we've got a spring and we've got a block, and like this is the roof or whatnot. We're just doing that. It could be the other way around, but I'm just drawing it like this. The period is t. If the spring and the block are taken to the surface of the moon, where the gravitational acceleration, so g moon equals 1/6 g Earth, the vertical oscillations will have a period of, okay, so the time period of a spring equals 2 pi times the square root of m over k. So if we look at this equation, we think to ourselves, okay, well, how could I solve this? How could I solve how the time period changes? I mean, of course, where's the g? And that's the very thing you have to notice. There is no g in this equation, so changing the g has literally no effect on the time period. So the time period on Earth equals the time period on the moon. It doesn't change. It's literally the same. So your time period on the moon would just simply be t, the same as it is on Earth, because the time period of a spring doesn't even account for a change in gravity. The gravity has literally no effect. Whether there's infinite gravity or no gravity, there's no effect on the time period of a spring. Okay, now on to, one second. This will probably be the last question for this episode. A linear spring of force constant k, so spring constant is k, is used in a physics lab. A block of mass m is attached to the spring, and a resulting frequency f is of simple harmonic motion is measured. Blocks of various masses are used in different trials. In each case, the corresponding frequency is measured to be recorded. If f2, so the recorded frequency, is plotted versus 1 over m, if frequency squared is plotted versus 1 over m, the graph will be a straight line with slope of. Okay, so this question is completely formula manipulation. So we know that time period equals 2 pi the square root of m over k. Okay? And so we know that time period equals 1 over frequency. So let's quickly square both sides to get m and k out of that square root. So we get 1 over the frequency squared equals 4 pi squared m over k. And so if we get f on top, to get f, because it's f over 1 over m, or plotted, so it would be f squared versus 1 over m. Sorry about the pause. One of my dogs wanted to be let in, so I had to, go do that. Okay, back to this problem. Okay, so it says f squared is plotted versus 1 over m. So to get this to where we can make it usable, we're going to flip both sides. So so essentially what I'm doing here is I'm multiplying across there, and dividing across there. But I'm just going to save some time and I can do it in my head, so I'm going to do it in my head. So we get f squared equals k over 4 pi squared m. So we can change this, or we can rewrite this as 4 pi squared times 1 over m. So, and it says f squared versus 1 over m. So to find the slope of this, it would be f divided by 1 over m, because that's how it's the same as saying like y versus x or whatnot. So to find the slope of this, we divide by 1 over m, and if we divide by 1 over m, what we're left with is k over 4 pi squared, and that's the answer. So the slope would give a value of k over 4 pi squared, which we should know is a constant because k is a constant, and 4 is obviously just a coefficient, and pi is also, it's a constant. I mean, granted, it's infinitely large, but it's, always the same value. So that is also a constant. So you would get a slope of that value. So hopefully you guys enjoyed this video. If you've got any more questions, be sure to visit my website, www.studysession.org. I will be happy to answer them. And yeah, hopefully you guys learned something, and I will see you in the next